In this video I want to look at how we actually solve equations, but we're going to use graphical techniques to solve them. So we're not going to work out the answers on our head, we're not going to work out the answers by algebraic techniques. I'm just going to look at the principles about how we use graphs to solve equations. I'm not actually going to do any of these because that's for another video. I'm just explaining the mechanics and the rationale behind why it works and what you need to do when you're trying to solve things graphically, equations graphically. So if I look at a basic equation, equation number 1, and I said, let's say we were trying to solve 3x plus 1 is equal to x plus 4. And I wanted to solve that by graphical techniques. The principle behind this is very straightforward. We are going to plot two graphs. The first of the graphs is going to be y equals, remember that the name of the graphs or the equation of the graphs that we generally tend to plot will start y equals all the time, and that's no exception here. So it's going to be y equals, and we take the left hand side of the equation, which is 3x plus 1. So we plot a graph of y equals 3x plus 1. That's the first graph. There will be a second graph. The second graph comes from the right hand side. The name of this second graph, or the equation of this second graph, will be y equals again, and then you take the right hand side, x plus 4. So we have two straight line equations or names that we need to use to draw two straight line graphs. Because we're getting two straight line graphs, which are linear graphs, that is the reason why the original equation is called a linear equation. The connection between straight lines and the algebra is the word linear. Okay, so we're going to plot those two. Now, if you're going to do this accurately by graph techniques, what you'd need to do is you would construct tables of values. A table of values for that and a table of values for that with x and y, work out some calculations, get some points to plot and plot them accurately on an accurate scale. Okay? I'm not going to do that. I'm just going to do a very quick sketch to show you the principles behind what we're doing. So if I was going to do a table of values and plot them, I'd get some sort of axes and some points, and I'd end up with two accurate straight line graphs. Now I'm just going to do the basic sketch of these two straight lines to show you the principle. This straight line, if I drew it accurately, plus 1 on the end means it would cross at plus 1 on the y-axis, and it's got a slope of positive 3, which means it's going to slope something like that. I could do this accurately, of course, that's what you should be doing to get the right answers. I'd label that, first of all, y equals 3x plus 1. Now, I do the same thing for the second straight line. Its equation is that, you get a table of values, you get points to plot, and if I plotted it accurately, this is what you'd get. Plus 4 on the end, it would cross somewhere up there on the y-axis at plus 4. Obviously accurately scale diagram drawn. And it's got a 1 in front of the x, even though you can't see it, it means 1x, which is a positive 1, so it's got a positive 1 slope. So in comparison to this slope, it'd be a lot more shallow than this, and so you'd probably end up with a picture that looked something like that. Okay, so this is the line y equals x plus 4. Now when you draw the two graphs, like so, you can see that they intersect at a point. That point there is known as the intersection point, and it's a very important point because it's that point that's going to give rise to your answer. Now I'll explain why it gives rise to your answer, but if this is a bit confusing for you, you don't really need to know why this works, you just need to know what you have to do to get the answer. So if this next 2 minutes confuses you, don't let that worry you, just learn the mechanical process of what you need to do and you will get your right answer. So this is the rationale behind it. For this first straight line that I'm looking at, this steeper straight line, it's got a name or an equation, y equals 3x plus 1. Well, that basically means that all the points that lie on that straight line must obey that rule. In other words, their y coordinate is the same as 3 times their x coordinate plus 1. That must be a fact for all the points on this line. Now for this straight line, the same sort of thing must be true, except this time that all points that lie on that line must obey this rule. In other words, their y coordinate must be the same as the x coordinate of the point plus 4. And any point which obeys that rule will lie on that line somewhere. Now that point there lies on both lines. So that must mean this point here must have a y coordinate, that is the same as the x coordinate plus 4. And it must also have a y coordinate which is the same as 3 times the x coordinate plus 1, because it obeys both of those equation rules. So if the y coordinate obeys both, what does that mean? It has to mean that the 3x plus 1 values on this line and the x plus 4 values on that line at that point there must be identical. So at that point there, this must be a true statement for the coordinates of that point. Now if you want to know what the x value is that fits this true statement, you can find the x value that makes that work simply by dropping down a vertical line to your x-axis and reading off the scale what that x value is. Now obviously this one here is a nice easy little equation which I could do in my head and work out. If you worked out what the answer to that was, you would get that the answer, I think, is going to be 1.5. It's a bit messy, but I think the answer is 1.5. Let me just solve it algebraically. 3x plus 1 equals x plus 4. Take the x over. 3x minus x is equal to 4 minus 1. Take the 1 over. So you get 2 x's on the left equals 3 on the right. So x is 3, share by 2, or if you like, x is 1.5 or 1.5. So that's doing it algebraically, but that's not the point of what I'm trying to do. That's not what this video is about. This video is about setting up your graph, doing it accurately. I haven't done it accurately here, and then reading off that. And if I was to do it accurately, I would find that that value there would be 1.5, which is obviously the correct solution. And that is the basic principle behind how you use graphs to solve equations graphically. And that is the end of this short video.